Alright guys, this is objective 3.2b, absolute value equations, but this time the absolute values are on both sides. So we're going to learn how to do that. We're going to learn how to solve them with absolute values on both sides of the equation. So let's start with the first window here. And what we're going to do is we're going to write like a paragraph here. And I've written most of it for you. Where we have a question at the top. We're going to start our paragraph with a question. We're going to answer that question, and then we're going to write our conclusion. So, given two absolute value expressions, we should ask, when are the absolute values of two expressions equal? So, let's say I'm given the absolute value expression of the absolute value of 2. And I have another absolute value of 2. And I set them equal to each other. That's obviously a true statement, because these two numbers in our absolute values are exactly the same. Absolute value of 2 obviously equals the absolute value of 2. That's a true statement. There is another way we could write this and still get 2 equals 2 and still use the same values. And that other option would be to say the absolute value of -2 equals the absolute value of -2. This is also true. It's 2 equals 2, and these values are the same. Okay, so 2 ways we can solve them when the values inside are exactly the same and end up with a true statement. But that's not the only way it could look, and this is the important part for you to understand, because I don't think that's terribly difficult for you to see that they're true. I could also look at them like this. The absolute value of 2 is equal to the absolute value of -2. Still true. They still have a value of 2, but this time the numbers are opposites. And there's one other way that could look. Anybody have an idea? The last combination? Go ahead. Exactly. Absolute value of -2 equals the absolute value of 2. All of these are true statements. So when we're solving equations with absolute values on both sides, we have to take into consideration that we have all of these options available to us, which means it's probably more than one solution that we will be finding. So, in conclusion, we've answered our question. Now we're going to summarize. So, 2 absolute values are equivalent when the expressions in the absolute value bars are equal to each other, or if they are opposite of each other. And that's the conclusion that we need to come to. We're going to be looking for 2 versions that will give us all of the solutions that we can find. Okay? So we're going to move over to window 2, and we're going to put this into practice. And this is just more of what we did yesterday, so it shouldn't be too difficult to do. We try to keep them separated. We'll solve one on the left and one on the right. The first time we're going to solve it, we're going to keep them exactly the same, so that whatever's inside the right will be what is, the left will be what is inside the right. So when we solve it the first time, we're going to drop the absolute values, we are going to drop the absolute value and keep everything else the same. So I'm going to mark those as both the same. I haven't changed them, and without changing them, when I finish solving, this should be a true statement. Okay? So what am I going to do first? Is I'm going to clear the fraction. So I'm going to multiply. I'm going to multiply both sides times 2 to clear the fraction. And I get 5x plus 2 equals -6. And then we'll continue to solve, subtracting 2 from both sides. and we get 5x equals negative 8. Divide by 5, we get x equals negative 8/5. We're going to hang on to that and check it in a sec. So, the first time we solve it, we leave everything just as it is and drop the absolute values. And we'll find the solution that will give us the same number inside both absolute values. The second time we solve it, we're going to keep the left side exactly as it is, but we're going to change the right side to be the opposite. Okay? So I kept this one the same, and I'm making this one the opposite. So this one stayed the same, but the right side became the opposite. Now you could probably just immediately see that that should be a positive 3 because it's the opposite of a negative 3, correct? And you may do that immediately, and that's okay. So we're going to get 5x plus 2 over 2 equals 3. And then we're going to solve it going through the same process of clearing the fraction, multiplying both sides times 2, and then going through the same process that we did before. 5x plus 2 equals positive 6, subtract 2. 5x equals 4, divide by 5, and x equals 4/5. Okay? So what we're going to do now is we're going to check these two solutions. We're going to check them. So the first time, just to recap, we left everything alone. Left everything exactly as it was, and we solved it without the absolute value. Second time we solved it, we left the left side alone and changed the right side to the opposite number. Okay, remember the answers because I'm going to erase the page. So we're going to do a check now on the original problem where we left everything the same. So plugging that in, writing it down. We're going to plug in, what was it, 8/5 or negative 8/5? Okay, so we're going to plug in a negative 8/5. Maybe I'll do that in a different color here. Negative 8/5 plus 2 all over 2 should equal the absolute value of negative 3. And you plug it into the original problem that you were given. And then you work inside. So this one won't be too bad because you can cross simplify your 5's. And you're left with the absolute value of negative 8 plus 2 over 2. And I'm not touching that right side. I'm going to leave it alone. I'm doing that for a reason. That gives us the absolute value of negative 6 over 2, which equals the absolute value of negative 3. We're going to finish it out. That gives us an absolute value of negative 3 equals the absolute value of negative 3. Now, when we do our check, when we haven't touched anything and we left everything exactly the same, these numbers should be the same. Which means that one of our solutions, negative 8/5, is a good solution. So I'm going to highlight the fact that when I plugged in the answer from when I left everything exactly the same, I got exactly the same numbers in my absolute value. Second time we solve it, we're going to plug in, what was it, 4/5? Yes? Thank you. So we're going to go 5, open up parentheses, plus 2 over 2 equals absolute value of negative 3. And I'm going to plug in 4/5, bless you. Then I'm going to work in my numerator, cross simplifying my 5's. So that gives me absolute value of 4 plus 2 over 2 equals the absolute value of negative 3. Or the absolute value of 6 over 2 equals the absolute value of negative 3. And finishing that out, the absolute value of 3 equals the absolute value of negative 3. Which is also true. They're true statements. But this time, when I made the right side opposite, I ended up with exact opposites inside my absolute values, which was supposed to happen. So when you're checking your answers, this is supposed to happen. Do you have any questions about that? Okay, then we will write our other solution, 4/5 in our solution set. I think I'll highlight my answer so that I remember to write it down. Okay, then I believe we can move on to the next window. That is not what I wanted to happen. Let's try that again. All right, here we go. So the next window. This one's a little different because you've got an X on both sides. But I think we're still in good shape. First of all, I'm noticing that both of these are positive absolute values, the positive out front and the positive out front, just like the last one that we did. So we're going to solve it 2 times. First time we solve it, we're going to keep everything the same, dropping the absolute values. So same on the front, same on the back. Second time we solve it, we're going to keep the left side, the same. But we're going to set it equal to the opposite. Now, are you guys okay with me doing the opposite right now? What's the opposite of 5x? And the opposite of -8? Of course, you can still write that negative times the quantity and distribute if you want, but this is what we're looking for to happen, to get the opposite values there. Then we're going to come over here and solve. So we'll subtract 5x from both sides. And since we're taking the x to the left, we'll take the 2 to the right through subtraction. And we get -2x equals -10. Divide by -2. And we get x equals +5. Not bad. Not too difficult. Then we'll go to the next one, where we're going to go through the same process. We're going to add 5x, bring it to the right, and we're going to take the 2, subtract it to the left. And we get 8x equals 6, divide by 8, and let's simplify 6/8 down to 3/4, and we get 2 separate solutions. We're going to check it, make sure we didn't make any mistakes. And I think I can probably just scooch this up a little bit. Well, I'm just going to erase. Hang on to my answers for me. So we'll start with, when we left everything alone, we were supposed to get a 5. So let's plug it in. 3 times 5 plus 2 should equal 5 times a 5 minus 8. So plugging that information in, we'll simplify that. So we get the absolute value of 17. That's not 17, that's 15. I'm doing the math in my head. 15 plus 2, which gives us the absolute value of 17. Just finish that one up. On the left side, or the right side, we get 25 minus 8, which is also 17. So you'll see that they are the same when I kept the problem exactly as it originally was. So that's one check. Our second check was 3/4. Remind me, 3/4? Yes? So we are going to plug in a 3/4. I should be doing that in red, but I think you get it by now. 5 times 3/4 minus 8. This one's going to require some thinking because I'm not going to be able to cross-simplify. I'm actually going to have to multiply a whole number times a fraction. So what I'm going to get here is a 9/4, 3 times 3 over 4. And I'd like to think ahead right now. How do I turn 2 in a number that's over 4? I will change it to 8/4. 8/4 is 2. I'm just imagining in my head putting a 1 under that 2, and then multiplying times 4 to get common denominators. Finish that side out because I can real quick. So that's 17/4. And then on the right side, I will start that process over. We're multiplying 5 times 3 is 15/4. And then I'd like to write the 8 as something over 4. So I think a 32/4, which also equals 8, will work. Do you agree? All right. Again, if you're wondering, I just tucked a 1 under the 8 in my mind and then multiplied times 4 in my head. And that gives me a negative 17/4. And this is still a true statement. They are not the same. They are opposites. Correct? And so my solution would be, somewhere you need to write it down. Our solutions were, not in orange, 5 and 3/4. Both of those solutions were true. And so there's what you do when you have an X on both sides. Last box has some special situations in it. When we look at the first problem here, what do you notice that's different than what we've seen so far? The negative right here. So how can a positive absolute value ever equal a negative absolute value? Is that possible? It isn't. Hello. Happy Thanksgiving. Thank you. Ooh, yummy. Popcorn. Thank you, Miss Mooney. All right. So, not possible? How can a positive absolute value ever equal a negative absolute value? Is that possible? So, no solution. It's not possible. It's not possible. Nothing you can do there. If they were both negative out front, then of course you could solve them. They'd both just be negative answers. But that's a positive absolute value, and negative is not possible. For a positive to equal a negative, it's not possible. Okay, so that one's an easy one. Just pay attention and be on the lookout for that situation because on your assignment it comes up a couple of times. Last one, here we go. Another special circumstance. So we have a positive absolute value equals a positive absolute value, so we're going to solve it twice. The first time we're going to leave everything alone, keep everything the same. Same left, same right. On the second time, we'll keep the left side the same, and we'll change the right side to be opposite. So we'll do a negative 3x and a negative 4. So we'll keep the first number the same, make the second number opposite, and we go back to solve. On the first one, you'll notice that when I move the 3x to combine like terms, that it cancels out on both sides. And I'm either left with the statement negative 2 equals 4, or if I add 2 to both sides, I'm left with the statement 0 equals 6. Well, that's not true, and that's what we call a contradiction. Now, this does not mean that we're done with the problem. It just means that it's losing a solution. We don't have a same solution. And I was on alert about that because those were both 3x's, but the rest of the problem or the rest of the binomials weren't identical. Let's go to the other one. We'll add 3x, and then add 2, and we get 6x equals negative 2. Totally doable. Divide by 6 and simplify. X equals negative 1/3. So that's totally doable, and that's when we did same opposite. Let's plug it in and see what happens. Let's plug it into the original. 3 times negative 1/3 minus 2 should be equal to a 3 times negative 1/3 plus 4. We should get opposite numbers in our absolute value. We are almost done. So what's nice about this is I can cross simplify my 3's, and get the absolute value of negative 1 minus 2. And I'll finish that out to the absolute value of negative 3. And when I go to the other side, canceling out my 3's, I'm left with the absolute value of negative 1 plus 4, which is a positive 3. So they're opposites, but that's okay because that's still a true statement. And so our solution is, again with the orange, negative 1/3. All right, so you have an assignment, and at the original I assigned all of the problems from 51 to 72, but I feel like, hey, it's Thanksgiving, so I'm going to have you do 51 to 71 odd with checks, and you can do 52 through 72 even with checks for extra credit. That's a total of 22 problems, by the way, so it's not like it's a lot. So I'm giving you 11 problems to do. We still have 30 minutes left to class. I think you can get 11 problems done in 30 minutes and not have any homework. So off you go. If you have any questions, let me know.